We physicists have waited 100 years since 1916 for this photograph.
Have you ever pondered the appearance of the early universe, the emergence and evolution of the first galaxies, and the hidden secrets they conceal? If so, you're not alone. Scientists have dedicated decades to seeking answers to these profound questions, utilizing state-of-the-art telescopes and instruments. Yet, occasionally, they come across something that defies their expectations and challenges the very foundations of their knowledge. This is where the galaxy GS 9209 takes center stage. Join us as we delve into the extraordinary findings and explore how James Webb Telescope astronomers discover massive ancient galaxies. GS 9209 is an ancient, massive, and enigmatic galaxy that pushes the boundaries of our understanding of the universe. Its discovery was made possible by the James Webb Space Telescope, the most advanced and powerful telescope ever constructed, capable of observing phenomena beyond the reach of any other telescope. The findings, recently published in the journal Nature, are based on data obtained by the James Webb Space Telescope, specifically designed to explore the infrared light emitted by the most remote and ancient celestial objects in existence. Scientists have recently discovered a very interesting galaxy called GS 9209. This galaxy is located so far away from us that we need a powerful telescope called the James Webb Space Telescope to study it. GS 9209 is about 25 billion light-years away from us, which means we are seeing it as it appeared 13 billion years ago when the universe was much younger than it is now. In 2004, scientists found something fascinating called GS 9209. They think it's one of the oldest known types of galaxies called quiescent galaxies. That's just a big word for galaxies that don't have many new stars being born. Astronomers are still figuring out a lot about these galaxies because there's much we don't know about them. Quiescent galaxies are usually really old, very big, and look reddish when seen through telescopes. But the coolest part is that they help us understand how the universe began. By studying them, we get hints about how galaxies change and evolve over time. What makes GS 9209 particularly remarkable and mysterious is that it's not only one of the earliest, but also one of the largest galaxies ever detected. It came into existence around 600 to 800 million years after the Big Bang. This means that GS 9209 represents a very early era in the history of the cosmos. Even though GS 9209 is about 1/10 the size of our own Milky Way galaxy, it has a similar number of stars. These stars, with a combined mass 40 billion times that of our Sun, formed at an incredibly fast rate. They formed within a relatively short span of 200 million years after the galaxy's birth. This means that GS 9209 was creating stars at an astonishing pace, producing about 90% of its stars in just 200 million years. On average, this amounts to around 200 times the mass of our Sun being converted into stars each year. This is quite different from the star formation rate we see in our Milky Way. Currently, our galaxy forms only about 1 or 2 times the mass of our Sun in stars each year. So GS 9209 had an intense period of star formation that was much faster and more intense than what we observe in our galactic neighborhood. This galaxy has presented us with a mysterious puzzle. Why did it stop making new stars? This galaxy stopped forming stars around 500 million years before we observed it with the James Webb Telescope. Normally, galaxies like GS 9209, which no longer produce stars, are found in the later stages of the universe's history when they have used up most of their gas or lost it through various processes. However, GS 9209 is unique because it is the earliest known example of a galaxy that has stopped forming stars, which is quite surprising and puzzling. One possible clue to this mystery comes from its supermassive black hole at the center of the galaxy. While most galaxies have black holes, this one in GS 9209 is 5 times larger than expected for a galaxy with this number of stars, which is unusual. Scientists believe that this large black hole might be linked to why GS 9209 stopped forming stars. Supermassive black holes can release enormous amounts of high-energy radiation, which can heat up and push gas out of galaxies. This process may have caused star formation in GS 9209 to halt, as stars form from clouds of dust and gas that collapse under their weight. The main questions astronomers are trying to answer about GS 9209 are: how did its black hole grow so large in such a short time, and how did it affect its surroundings to stop star formation? To find answers, scientists are studying GS 9209's light emissions at different wavelengths, known as its spectrum, and its appearance, shape, size, and structure, known as its morphology. This analysis can reveal information about its history, evolution, gas content, metal composition, and kinematics. By comparing GS 9209 with other galaxies at different stages in the universe's history, astronomers hope to understand better how it fits into the larger picture of cosmic evolution. So what can we learn from a galaxy like GS 9209 about the universe? Well, quite a lot. GS 9209 is not just an ordinary galaxy, it's like a window that allows us to look into the past. It shows us how galaxies were formed and changed in the early universe, and how they interacted with their surroundings and their supermassive black holes. GS 9209 also challenges what we currently believe about how galaxies are formed. Our current theories and models of galaxy formation didn't predict the existence of such massive and calm galaxies during the early stages of the universe. This means that GS 9209 might represent a new type of galaxy that was created through different processes compared to other galaxies. Perhaps GS 9209 had some unique conditions that enabled it to form stars very quickly and efficiently. For example, it might have had a high density of gas, a strong magnetic field, or it might have merged with another galaxy. On the other hand, maybe GS 9209 had some special mechanisms that abruptly stopped the formation of stars, like a powerful impact from its supermassive black hole or a strong wind from nearby stars. These are some ideas that astronomers are testing to explain the existence of GS 9209. However, they need more data and observations to confirm or reject these hypotheses. They also need to find more galaxies similar to GS 9209 to understand how common or rare they are during the early stages of the universe. Luckily, we have a powerful tool called the James Webb Telescope that can help astronomers with this research. James Webb is not only observing GS 9209 but also many other galaxies in the same area of the sky. This specific region is known as the Cosmic Evolution Early Release Science (CEERS) survey, which covers a portion of the sky close to the Big Dipper constellation. This area was chosen because it has fewer bright stars and galaxies in the foreground that could interfere with the observations of distant objects. By studying this region with the James Webb Telescope, astronomers can observe hundreds of galaxies that formed within the first billion years of the universe. Some of these galaxies are even older and farther away than GS 9209. Additionally, they range in size and activity, with some being very massive and calm, while others are small and active. All these different galaxies are challenging our current theories and expanding our understanding of the universe. The revelation of a massive ancient galaxy leaves us in awe of the limitless wonders that the universe holds. The discovery serves as a significant milestone in our quest to understand the origins of our cosmos. By unraveling the mysteries of this colossal entity, scientists can gain invaluable insights into the early stages of galaxy formation, providing a glimpse into the birth of our universe itself. So keep your eyes on the skies, for the next revelation may be just around the cosmic corner, waiting to astound us once again.